What I want to also share with you people is that when the financial crisis started, there was a moment before Lehman Brothers went bankrupt where the Federal Reserve asked the major banks in America to make a simulation of the implications on their business if the Federal Reserve would let Lehman go bust. And there was only one bank, it's the one where Jack was working, that was able to produce these numbers in 48 hours. And later it turned out they were less than 10% of the actual damage that they got from Lehman sinking. The next one was Stanley Morgan. It took them more than 3 weeks, and they were more than 40% off. And that leads him to strongly argue for the importance for massive computational power right now and rapidly growing in the future. And by now, the other banks have catched up and are also in the same ballpark as he signaled at some stage. So I'm sorry the communication was so bad, but I think for us it's really, really important to be aware of what these people are doing and to think about how to relate our kind of work to these realities.
It's a delay. The question, he talked about scenarios and positions. Is it similar to what you talked about in terms of contagion risks, or it's just the positions are the first neighborhood effectively of the kind of calculations that you're talking about? It's very hard to figure it out, but it makes a big difference, of course, and the internal representations that they have for each of the banks. Also, it connects back to the second speaker, because if their positions have respect to the holdings that their investors have, then that affects their ability to collect the debt as well. I do not know how it works. So.
Now, it may be useful to tell those who are not familiar with these things that the standard modeling tool used in looking into financial markets in the economics profession are the so-called dynamic stochastic general equilibrium model, as DSGE models. They are stochastic, but basically they just track half a dozen aggregate variables. And what we had in all the presentations was examples of the need for a really deeply different kind of models. And Sarah quoted the paper from the 50s that has been reprinted in this Journal of Microsimulation, where already decades ago an econometrician said, look, we cannot live with these simple aggregates only. They are useful, they're relevant, but we need something completely different. I don't think at the present stage we have this something completely different, but I'm really impressed. We had Stefano Battiston, we had Stefan Turner, we had you from the Bank of England, we had the man from the World Bank, we had Jack, even with poor communication, from Credit Suisse. It should give us a sense of the direction into which these things are moving. And frankly, Rob is one of the leaders, not starting now, but starting many years ago, in really doing fine granularity models of these kind of things. It is more important than most people realize, and it is really, I think, intellectually speaking, one of the more exciting activities. We are far from having the tools that are needed to deal with the next crisis and to deal with poverty, inequality, and environmental issues. So that's the picture that I have about the whole situation here. And because you, Guido, are familiar with the network approach to these things, which is, I think, the big alternative, perhaps you can expand a little bit on this.
Yes, I would like also to mention the group of people here in Lucca, Tiziano, Giulio, Fabio, who has a life other than organizing conferences as a scientific figure. And one of the now we have Marco that is a regulator. One of the main problems that you face when you would like to work with financial data is the lack of all the relevant information, because of various reasons, because of privacy, essentially, because people or institutions don't ask all the data that they need. So one of the things that we believe we can help with, and this is what we're doing, is this reconstruction of networks. So the possibility to have a measure, a statistical measure of how plausible are our hypotheses on what's left, what we don't know, okay? And to use these measurements to do more efficient stress tests. Okay, so this is one part of this puzzle of competences that is often forgotten. So thanks for this opportunity to add this piece on network theory.
So maybe I can add something of what you said. It's similar but a bit different. So I think he was talking about an even deeper level of granularity. So positions, he means essentially contracts between Credit Suisse and its counterparts. And in my model, in this model at least, you somehow aggregated over all your exposures with another counterparty over a certain class of exposures that you expect to behave in the same way. So there was an even deeper level. This is why they have 11 million open position currently, and they have to very detailed. So they can then mark them to market under all range of scenarios in a very detailed way. But it is true that they miss the farther rounds of propagation if they were to be there. So there's only someone with the full information can do that. So yeah.
Okay, it's 4 o'clock. I think we want to move forward, but I definitely want to have the possibility in the room to share further comments, thoughts, remarks. I will have one of myself, but perhaps after the break. Madhav.
To me, this is very exciting. Chris can say more. He's 100 years old, as you know, so he's done stuff before. We actually build out a model for markets, especially electric markets, in 1997 or so. Yeah, when actually we did it when the Enron crisis had just begun and EPRI had given us a contract. We had represented firms then, nothing close to what Rob and the researcher from Austria talked about. We had done some contagion modeling as well, but so this is very interesting how it has come together and the challenges you have posed. I'd like to know more about it because I think there's much to be offered, and he started the talk very nicely by saying very strong relationship to epidemic modeling. And Haldane and May's paper also talks about it, and I do agree with it, at least at a high level this is the case. So I think you have not taken the synthetic information into account, and we heard a little bit of that. So it's possible to put all this together in a very interesting economic modeling situation, which can be useful. So I look forward to this interaction.
I just want to add one thing to that. In the power market that we had different kinds of contracts, like very spot contracts through, assured power market contracts. But the most important thing is it was tied to the actual physical delivery and the demand side modeling of the population. So it was actually in the independent system operators clearing level of detail that those markets happened. And it's pretty interesting because it's coupled to both the demand side behavior of the individuals and the physical distribution system.
Okay, then I just want to say that getting in touch with, let's say, this kind of challenges and the people working on them is one reason that I absolutely want to continue this line of work in the years to come, and to work much more closely with some of the people and institutions, including your institution, in the years to come.